right, another day of AP Calculus. Today's date is Wednesday, October 9th, 2019. All right, we're on graphical analysis still. So if we look at our unit guide, graphical analysis, we're still here. Tomorrow's our last day of graphical analysis, and then we move away from graphs, and you just get equations. So coming back here, okay, this is kind of a weird day because everything that we've done up to now in terms of definitions is f prime bigger? Does f prime change signs? Does f prime blah, blah, blah? Today is different. Today we're talking about f double prime for our definitions. So be warned. Our objective today, someone read it.
Find where graph of f prime and f double prime are concave up to concave down and have any inflection point.
There it is. Okay, so let's go ahead and define those things because I'm sure only maybe a few of us know what an inflection point is. Maybe Claire knows it in German. Concave up, we know what that means in terms of its graph. But here's the formal definition that you have to have memorized. It's no longer f prime, it's f
Double prime.
double prime. F double prime, and what are you going to guess here?
Greater than 0.
It is indeed greater than 0. The second derivative is positive. And someone shout out, concave down is going to be what?
Double prime less than 0.
There it is, f double prime less than 0. Ooh, what about this one? So FIP is very similar to relative extrema, but with f double prime.
F double prime equals to 0.
So that's not where, so that is a CV.
Sign change.
It's a sign change. Remember, relative extrema is a sign change, and FCV, or a critical value, is where it's equal to 0. In order to have a relative extrema, this is all review, in order to have a relative extrema, I first find the CVs and then check whether or not there is a sign change. So FIP, F inflection point, is where F double prime has a sign change, which will always happen where, I mean, you could have an F double prime DNE, but usually you're going to have an F double prime equal to 0. There's no such thing. If I have f double prime equal to 0, there's no name for that. There's no equivalent of a critical value in the second derivative. So you don't have to worry about that. But in order to find an inflection point, you do need to set that equal to 0 and then solve, generally. So let's talk about this. If I have a graph of f, let's annotate, where is it concave up?
Go there.
On the right or the left?
Right.
Right, yeah. This is all concave up, concave up, concave up. So we can say over here it's concave up. I'll say concave up like this because f double prime is greater than 0. The second derivative is greater than 0. You can't really see the f double prime, but it is f double prime is greater than 0. What about f double prime less than 0? Do you have any concave down? On the left, on the left. All this stuff is concave down, concave down. If I went from concave down to concave up, that means I went from a positive to a negative. That implies that there is a sign change. Anyone want to guesstimate where that is? Draw it on your own graph. Let me see if you can get it.
Right here.
Let's see. You guys got it?
Right here.
Not quite. So the concavity changes, and it's kind of hard to see just on the graph of f. On the graph of f prime and f double prime, it's very, very clear.
Oh, I got you. You're like right there.
It's right here. It's right where it straightens out. I'm still curving down at this point. I'm still curving up at this point. And right in between there, I have an inflection point where I change concavity. So this right here is an FIP, inflection point, because I changed concavity. I went from concave down to concave up. All right, so now we have a graph of f prime. Notice that this was f prime, f double prime. I literally took the same function and took its derivative. That's what its function looked like. Tomorrow, you're doing curve sketching, so tomorrow you have to do this. If I give you a graph like this, you need to use all the knowledge that you've gotten in terms of concavity, concave up, concave down, inflection point, everything you need mastered in order to do tomorrow's lesson, curve sketching.
I hate curves.
So it is hard. So here's a graph of f prime. Go ahead. Where is it concave up and why?
Right there in the whole graph.
The whole graph is concave up.
Yes.
You're correct that it is concave up. Where is f double prime greater than 0 though?
Isn't it where slope? It's slope. Where's right?
Write it down. F double prime is now slope.
Oh, the slope.
I should have written back here f double prime concavity.
Well, one of the like trick steps for the homework is when you look at the graph, circle whether it's f prime or f double prime or whatever, because you'll always forget. And if you circle it,
Yeah.
important.
Circle those. They're important. All right, so f double prime is slope. So where is the slope positive for concave up? Where's the slope positive?
On the right.
On the right. Well, that makes sense because it lines up over here. So I have a slope that's positive, so that means I have concave up. Or not concave up. The function is concave up, so f double prime is greater than 0. Where is f double prime less than 0? On the other side, because over here the slope is negative, so this is f double prime is less than 0. Where's the slope change signs? Not where the slope is equal to 0, which happens to be the same point in this case. Where does the slope change signs here? Right there. Yep. This is an FIP. It just happens to be where it's 0. Can you guys imagine a graph that has on a graph of f prime, the slope is 0, but it's non-IP? Can you visualize what that looks like?
Straight line.
Oh, where it goes like.
Exactly. Yeah, those are called saddle points. So draw it out. It looks like this, where it comes out, and instead of coming back up, it goes back down. Ha ha! Tricked you. It didn't change signs. It's still a slope that's negative, still a slope that's negative. Well, it could have been an inflection point. It didn't go back up, so that is not an IP. Not an IP. Not an inflection point. Because it was a negative slope, and it's still a negative slope. All right, on a graph of f double prime, what is f double prime? Height, slope, or concavity?
Height.
Height.
It is indeed height. So f prime is now height. F double prime is height.
Is double prime or triple prime?
F double prime is height because we're always matching the definition. What is f double prime? What is f double prime?
It's like we don't even think about f double prime like ever.
Ever. Yeah, don't worry about jerks in this class. F double prime is height. So where do I have a positive height?
On the right hand side.
On the right hand side. Right here on over. Not including that point, I have f double prime is greater than 0, and then over here, obviously, the height is negative, f double prime less than 0 over here. And where is my height, because I'm talking about height now, height sign change? I'm just matching the definition. That is right here, the x-intercept is our inflection point. That's our FIP. Because we had a sign change. Can you guys visualize on the graph of f double prime where you would have something that touches the x-axis but doesn't go through it? Yeah, there's a few different options, right? I could have something that looks like this, that's continuous and differentiable. I could have something that's continuous and not differentiable that still touches. I could have a V, boink, boink, or just touches and then turns around. As long as you have a sign change, it should go through the x-axis and then you're good. So make a note here, has to go through the x-axis on a graph of f double prime. Through, I don't have any room here. I'm going to squeeze in right here. Through the x-axis. If it goes through it and doesn't turn around, then that's an inflection point on a graph of f double prime. All right, so here are some examples. These are kind of like homework problems. I have G, H prime, and J double prime, totally unrelated graphs now. So on a graph of G, where is G concave up? What is the definition of concave up, by the way?
F prime.
Or G double prime
Greater than 0.
greater than 0. So where's G double prime greater than 0?
On the right hand side. Everything.
Everything is concave up. Nothing is concave down. So everything. So we say, here is your interval notation. Interval notation, you say everything. Negative infinity to positive infinity. Everything is concave up. And for your inequality notation, inequality notation, you can just say all real numbers. You can say two things here. You can say, let's just stay with blue. All real numbers, or all solutions. Or if you're a fancy pants, you can do the symbol for all real numbers, which is a bold R, or double lines over here for an R. That is the symbol that says all real numbers. All right. Where is my graph of G concave down? Nowhere. So I'm going to say not applicable. NA. Not applicable. Can't do that one. Nowhere is it concave down. What about an inflection point?
It Middle.
No, it doesn't exist because
Yeah, again, it's not applicable because we don't have any change of concavity. If you never have both a concave up and concave down, you don't have an inflection point. All right, so far so good. Let's talk about H prime. So on the graph of H prime, what is H double prime? H double prime is now
Slope.
slope. There we go.
slope. All right, so what is the definition of H concave up again?
H double prime is greater than 0.
And I should have put this one down here, G double prime less than 0. And what is inflection point? It's G double prime
Changes signs.
sign change. There it is. All right, so since we're looking at a graph of H prime, it's kind of hard and maybe confusing to think of H concave down. If it was H prime concave down, it would be super confusing. It would be the concavity of the graph. But in order to find the concavity of just a plain old H, I'm looking at H double prime, and we know we're looking at slope here. So where is the slope positive? The left side. How do we say that in interval notation? To this x coordinate right here of 1. So does it include 1 or not include 1? Not include, because we have a slope of 0 at 1. So not including 1. All right. How do we say that in inequality notation? X is less than 1. Oh, that's a 0. X is less than 1. As simple as that. Everything to the left of 1 is H double prime less or greater than 0. All right, Gio, give me the definition. H concave down.
H double prime minus less than 0.
There it is. So H double prime is less than 0, and since H double prime is slope, where is the slope negative?
So from negative positive.
From positive infinity all the way out here on the right to...
What's that for me? 8.
Careful, I still have a negative slope right here, which is to the left of 8. That's still a negative slope. This is a positive slope. So it goes all the way to right here, everything to the right of that.
1 to negative or positive.
1 to positive infinity. There it is. 1 to positive infinity. And Gio, should I include 1 or not include 1?
No, include 1.
Include 1. You say at 1 I have a negative slope. This is a negative slope right here.
No.
Oh, it's not. It's a negative slope. So I can't include 1 then. Okay.
Wait, do you want to repeat how you write that? Because I get it, I don't understand why the one's first.
So you always go from left to right. Positive infinity is over here on the right, and 1 is here on the left. So I go from left to what? Right. 1 to infinity. I mean, technically, you're not wrong by saying infinity to 1. It's still in that range. It's just normally we write from left to right because it's the English language. I wonder if in China they're like, oh no, you can write it infinity to 1 because it doesn't matter the direction for Chinese characters. I'm curious. I doubt it because usually math is a universal language. How do I do this in inequality notation? How do I say everything to the right of 1? X is greater than 1. There it is. Give me the definition of inflection point, Arrow.
H double prime sign change.
H double prime sign change. All right, where did I change signs?
1.
At 1, at x equals 1. Done. Bless you. All right, we're on a graph of J double prime. So if I'm looking for J double prime, because that's the definition that I'm matching with, J double prime is what? Height, slope, or concavity on this graph?
Height.
Is height. And I guess to be consistent, G double prime is concavity. All right, so Sego, definition. J concave up is...
J double prime is greater than 0.
All right, and then where is that? J double prime is height. Where's the height greater than 0? So the height, where is this height above the x-axis? Between 1 and... You're saying over here is above the x-axis? No, so between 1 and 9. Do you include 1? Nope. Do you include 9? Nope. There it is.
Wait.
I don't include 9 because 9 is on the x-axis. I need to be above the x-axis. So everything above the x-axis is concave up. Who can turn that into inequality notation?
Wait, is it concave up or concave down?
It's concave up because it's up above the x-axis.
Oh.
It has a positive height. Where do I have a negative height on this graph? Oh, sorry, I jumped down here. I apologize. Rewrite that. I'm converting to inequality notation. How do I say in between 1 and 9? In between 1 and 9. So x is in between here, right? X is in between 1 and 9, and what symbols do I use?
So 1 is less than x, which is less than 9.
Just less than, less than. No equal to, because it's not a closed bracket, just less than, less than. 1 is less than x, less than 9. X is in between 1 and 9. That's how you write it in inequality notation. I'm not going to force you to do one or the other on test. You need to figure out which one suits you, but you do need to write them down for the notes. If you like between 1 and 9 this way, just write it that way. So far, so good? All right. And where is J concave down? All right, there it is. There's the formal way of writing it down. Whenever you have two different intervals, you usually separate that by an or, and that symbol looks like that. It looks like a U. Or sometimes people make it like a V. Just some symbol that looks like that to say these two intervals, but not overlapping. Because if they're overlapping, there is no overlap, and you'd have no solutions. And then you'll have another or symbol because you can't have overlapping. How do I say everything to the left of 1?
X is less than 1.
X is less than 1. No, that's why do I keep doing that? And then how do I say everything bigger than 9, Gio?
X greater than 9.
Greater than 9. There it is. There's your inequality notation. And finally, where do we have an inflection point? Where do I cross through the x-axis? Where do I change signs in terms of the height? Height change signs. I had a negative height, then a positive height. Where did that happen?
At 1.
At 1 and
9.
there it is. That's all I have for you guys.